So good afternoon, students. So today we'll be discussing welding, and mainly two types of welding we'll be discussing today. That is thermit welding process and resistance welding process, right? So coming to the thermit welding process, what basically is thermit welding? So let us look into few important factors about thermit welding. First and foremost, the factor is that thermit welding is your is such a process in which the electrical connection is not required, right? You don't need any electrical connection. Okay, it is done by some chemical reaction. So thermit welding is a chemical reaction based process. Okay, and what exactly happens in the chemical reaction? It's an exothermic reaction that takes place, right? Let me quickly open the slide mode in the PPT format, and I'll share the slide. Okay, I believe all of you are able to see. Okay, now this thermit welding process is process which is a which has a very violent reaction. Okay, and it is an exothermic reaction takes place, and due to that exothermic reaction, heat is generated, and the heat uh, melts the iron. Okay, so we get the it's a, you can say, a molten iron is formed, right? And we can deposit that molten iron in the weld gap, and we can get that welding done. So let us look into the process, how the process goes about. So basically the purpose of the thermit welding is to observe that the extremely violent reaction that leads to one of the formation of the oxide. Okay, formation of iron from its oxide, like from the iron oxide we get iron. Now what happens? The metallic mass of iron that forms beneath the slag at the bottom of the crucible. So we'll see a video here which will help you to understand. However, let me quickly demonstrate the process to you first, then I'll show you the video. So the reaction is very energetic and exothermic. So the possibility of explosion if water is present in the thermit mixture, the temperature is around 4500 degree Fahrenheit, right? So let us quickly see the reaction, or the video rather. I'll quickly share the video with you people. So here we have the video.
Thermit welding is carried out. Let us weld two railway tracks along their ends using thermit welding. First, pour the hot molten wax between the gaps of the tracks to form a wax pattern. Then install a welding setup around the rail ends as shown. Now bring a box containing thermit mixture, which is basically a mixture of aluminium and iron oxide.
So inside the thermit box, we have a mixture of aluminium and iron oxide.
Igniting mixture like barium peroxide.
So barium peroxide particles are present, which are used to ignite the mixture. So the box is placed on the top of the setup. This is the cross-sectional view of the thermit. The whole mixture is ignited, and due to the ignition, there is a reaction takes place. So aluminium and iron oxide both react with each other, and aluminium, what happens, it forms aluminium oxide, and we get iron out from the ferrous oxide. Okay, and this is an exothermic reaction. So we get a superheated molten metal of iron and molten aluminium oxide. So this molten iron is deposited on the gap, because molten iron is heavier than the aluminium oxide.
Out of the box from the opening present at the bottom of the box and enters the welding setup which consists of a cavity around the joint. The extra molten iron then moves out of the cavity and falls on the tray. Now leave the molten iron for some time to solidify around the joint.
So there are some time allowed for the molten metal to solidify. Once it is solidified, the arrangement is removed.
We see that the solidified molten iron is formed at the joint. Note that the extra iron metal
We can remove it using a grinder, and we can join the two railway tracks using this method. Right? I believe all of you were able to understand the process. I'll quickly unmute you for 1 minute or two. Okay. In case you have any doubt. Okay. So were you able to understand the process? Was the audio in the video clear?
Yes, sir. Yes, sir.
Okay. So in this process, what exactly happens is the iron oxide get mixed with get or reacts with the aluminium, and since aluminium has a high affinity towards oxygen, it forms aluminium oxide, and iron is taken out from the iron ore, right? And due to this and also the reaction is very much exothermic in nature, so around 4500 degree Fahrenheit temperature is raised, and due to this what happens, the molten iron, now we know that iron is heavier than that of the aluminium, so the aluminium oxide floats on top, and the iron moves down into the gap, right? And if some time is allowed for the solidification process, you can say this process is similar to that of casting process also, right? Because now the molten metal concept is already there, right? Okay, so I'll move forward. I'll put you on mute again. Now moving ahead, I'll move back to the slide once again. So the concepts of Thermit welding process is a single replacement reactions takes place. So exothermic reaction takes place, redox reaction takes place. Redox means reduction and oxidation reactions. You know these things. You have studied these things in chemistry. So now single replacement reaction that takes place is aluminium gets or reacts with ferrous oxide, and it becomes aluminium oxide, and it gives out iron. Okay, so oxide anions are transferred during the reaction from iron 3 oxide to aluminium. Okay, oxidation number of Fe is 3 plus in starting material and 0 in the product, right? Now oxidation number of aluminium is 0 in the starting material and 3 plus in the product. So oxidation number of oxygen is taken as 2 minus. Exothermic reactions, heat flows out of the system, surrounding heats up. So the surrounding of the system heats up. The amount of energy, which is around 730 kilojoule per mole, that is around amount of energy that is generated. Okay, and further redox reaction takes place. So transfer of electron reaction, redox means reduction oxidation. So aluminium gave its electrons to Fe2O3. Aluminium was oxidized, and Fe2O3 was reduced, and we get iron. So what is the conclusion? Single replacement reaction defined by the transfer of oxide anion from Fe2O3 to Al2O3, right? So reaction demonstrates concept of heat flow. Aluminium gave up electrons, so it is a reducing agent. Fe2O3 gained electrons, so it's an oxidizing agent, right? So now what happens is the normally this process is used in case of your joining of railway tracks, right? Railway track joining is one of the main important application of this process. However, this process is nowhere demonstrated in any kind of university or school or of mechanical engineering, okay, or a school of polytechnic, because it's not a very safe process, is very dangerous for students to perform. And since the exothermic reaction takes place, so highly trained people on thermit welding go ahead and perform this kind of process, right? So demonstration I already showed you in the video. Okay, so this is some photos which you can see that before. This photo shows you that what is the uh, I'll mark it on the diagram. So this is your thermit box. This is your thermit box. This is the mold which is made, okay, and this box with the mixture of Al2O3, aluminium plus Fe2O3, Fe2O3, I am not able to write here properly. Okay, so Fe2O3, this is called the thermit mixture. Okay, thermit mixture. Now this thermit mixture, when barium peroxide is mixed with it and ignited, highly reactive or high exothermic reaction takes place, and this aluminium becomes aluminium oxide, reacts with get oxidized and becomes aluminium oxide, and it reduces the iron, and iron in it gets converted into molten metal. So you can see from the second diagram here, okay, what is the amount of heat that is generated, and a fire kind of thing is coming out, which is not very safe for students to use, or rather the people who perform this welding needs to carry out some safety precautions before they carry out this kind of process. Okay, so this is normally we can see by the railway tracks, by the side of the railway tracks, in case some of the thermit welding some thermit welding is going on, that is two railway tracks, they are joined, and this process is done in the railway tracks only. This process is not done in the railway track manufacturing company, right? Because when you place the railway tracks, you come to know that this is the place where you have to join, and then now you may ask this question may arise in your mind, that in your school days that you have read that there is a gap between the railway tracks which is maintained, and now I'm talking about joining that gap. Now here, I'm not talking about joining that gap which is maintained. That gap is a different gap altogether, which is maintained for the sudden expansion and contraction of the railway track, which takes place while when the train passes on the railway tracks, and due to the huge amount of friction, the heat is generated and certain expansion takes place. So that place or that gap is maintained, that gap is kept. I'm not talking about that gap here, or filling in metal in that gap. Okay, suppose you have a railway track, a long railway track. Suppose, for example, I have to keep a railway track of around 50 meter, and I have around 10 meter sections of rails, right? So in 4 places I have to join them in order to keep a long track. Then after 50 meter, there is that gap which you have studied in your school days, right? So don't mix these two gaps with each other. The gap which you have studied in the school days, that is already there in somewhere else. However, this gap which I'm talking about is the gap provided so that we can fill in the metal and we can join the two tracks together, right? I believe this is clear. In case you have any doubt, you can ask me during the question answer session. Next is, what are the advantages of this process? There is no power supply is required, so we can also perform this welding where there is no power supply. As we can understand, in some railway tracks, in some places there are railway tracks placed which have no power supply nearby. Okay, now as till date there are some diesel engines they run. Okay, because due to the lack of power supply in those places. So even in those places we can use this kind of process, thermit welding process. And apart from railway track welding, other complex shapes, suppose we have a die, permanent die of any casting, right? So you have a permanent mold, and you have been using that permanent mold for casting several small castings, and you are using it for a large scale production. Due to some reason there is some fracture, or your die breaks into two pieces. Okay, so you can again use this kind of welding process to join that kind of die. So any kind of complex shapes can easily be joined, because the rest of the place you can fill it with sand, and you can only allow metal to pass through the gap where the crack has taken place. So you can just do some kind of grinding operation to create the gap or enlarge the gap, and then you can just make sure that the molten metal flows into the gap. This arrangement is very simple, inexpensive. However, it is not very safe to use for the students to use. Yes, disadvantage. As I told you, not a very safe process, because high energy process, exothermic reaction takes place, high heat is generated, so high skill is required, right? So the people who are working or who are performing the thermit welding process needs to have high skill. Okay, so at times they require some kind of certification for thermit welding, and without which they are not allowed to perform this welding. Slag inclusion. Slag is the when there is some flux material which reacts with oxygen, it becomes slag. So since this is similar to that of the casting process, where molten metal gets deposited into some cavity, so chances of slag inclusion are also there, because slag inclusion, if you remember, we have studied it as a casting defect, right? The deposition rate is very low, and the operating factor is also like you can say that deposition rate depends again on the uh, size of the thermit box. Okay, so these things are you have to be concerned about. And again, when the reaction is taking place, there is a high level of fume that comes out, as we have seen in the previous diagram, this one, that high level of fume comes out of that this cylindrical container where the thermit mixture is there. Okay, because the exothermic reaction takes place, high heat is generated as if it is being fired. Okay, so high level of fume, which is not very safe for people to be there. Okay, next is hydrogen control thermit welding. Advantages, disadvantages are there. Like uh, now if hydrogen comes in contact with this, there is a defect called hydrogen embrittlement. Hydrogen embrittlement, that means the hydrogen, if in case gets or we can say gets in contact with this hot metal, the metal becomes brittle. Okay, and for low melting point metals, it is not recommended, like for metals like lead, tin, zinc. Okay, or metals like titanium, which are very much reactive in nature, these processes are not recommended for that. The defects that we encounter in case of thermit welding process are porosity, inclusions, some incomplete fusion is there, some cracks are generated. Okay, some shape defects. Shape defects, what is this shape defects? That is, suppose you have provided sand on the sides. So if I show you the video once again, let me quickly get back to the video. Uh,
Thermit. Place this box on top of the welding setup.
right. Okay, let me stop here. Now see, you can see here that there is a gap. Okay, on the sides,
Ignite the whole mixture.
see, this is the cross section of this railway track, right? On the sides, if you don't place anything, what will happen? This entire mixture will get overflown here. Okay, so you have to remove a lot of material then. So what we do is we provide some amount of sand here.
We see that due to fire, both the aluminium and iron oxide react with each other. As a result, aluminium, which has high affinity with oxygen, reacts with the iron oxide to form aluminium oxide and iron. This reaction is exothermic in nature. Thus, a large amount of heat gets released, and this results in the formation of superheated molten metal, which consists of molten aluminium oxide and molten iron. We see that the molten iron being heavier welding setup, which consists of a cavity around the joint.
Right. See,
The
in
extra
this
molten
case,
iron then moves.
what they have shown is the entire metal is filled up in this cavity, but that is not the case. We have some sand here. Okay, so some sand, you can say some mold kind of thing is there, and it is, the sand is surrounding the railway track, or rather the gap. So the gap here is the mold cavity, and the metal falls into the mold cavity, right, which has been shown at the last. So after this removal, if you see, after this is removed, see, this is the mold. Okay, so this is the only part which is having the gap, and after it is solidified, we get this. Some of the extra material can be there, which can be removed using grinding. Okay, but not the entire bulk of metal, because in that case, what will happen? There will be loss of metal, as well as extra reaction will take place. More material, more reaction will take place. That is also not recommended, right? So let me get back to the slide. I was talking about defects. So since we have related this process somehow with the casting process, this process is similar to that of the casting process. We have found that this process has similar kind of defects which we encounter in case of casting, right? In casting also we see that these kind of defects arise. So porosity, inclusions can be slag inclusion, can be sand inclusion. Incomplete fusion may take place, again similar kind of defect as we have read in case of casting. Cracks may be generated, hot tears may be generated. Shape defects like misalignment. In casting we have studied about something called mismatch, or we can say the cope and drag do not match with each other. Shift, so in this case some other misalignment may take place, and it may also happen that it is not properly in the shape, because it may happen that the metal got solidified due to many reasons, maybe due to lack of flowability, lack of pouring temperature. These things have already been discussed, if you remember, about or when we have uh, when we have the casting process. Okay, now I see in the chat box that Pritam has asked, what is operating factor? Now operating factor is, you can say that operating factor is the safety factors while the operation is being taking place. Okay, so when your performing some kind of operation or you're performing any kind of process, okay, what are the measures that you have to take? That is your operating factor in this case. So low operating factor means the operators have to be very much skilled, else if an unskilled person comes in, it will not be it will be harmful for that person. I believe your question has been answered, Preetam, right? Okay. In the group, I'll also request you to just post your roll numbers so that I can also get an attendance here. Okay. Please post your roll numbers. Okay. And I'll request Preetam, in case your doubt has been cleared, you mention yes, or you can ask more question. Okay. Here. Okay. Now, this is the end of this your thermit welding. Okay. So what I will do is I have 10 more minutes. I'll request you to ask questions or discuss about this. I'll unmute you. I'll just uh, stop the sharing here, and I'll open here to for the question answer session. And in the next session, again, after this ends, after this meeting ends, again we'll start with the same link, and I'll discuss about the resistance welding process. Okay, right. I'll request you people to, you can turn off your video, right? Your video is not required. You unmute yourself and you can ask any question, or you can point out anything which you have not understood. Okay. Yes. Is there any query regarding the process?
No, sir. It is clear, sir.
No, sir.
It is
It is
clear?
clear, sir.
Okay, so this is a very simple process. In case you get this kind of suppose you have it in your question paper that please explain the thermit welding process. I'll also provide you with this video. I'll upload it in the YouTube, and I'll give you the link. And along with that, I'll also send you a few study materials so that you can study things in detail about this welding process. Okay, because questions, MCQ questions may come from very intricate things, like even in case of the structure of the welding. If you give the test today, you will understand that you have to know about the parts. Okay, like as I told you, the top part is the place where the container where the thermit mixture is there, and then there is a place where the sand is packed in. So you properly have to go through the diagram. You have to understand the diagram and accordingly answer, right? Okay. So how are you feeling on this online teaching learning process? Is it okay with you?
Yes, sir. It is okay.
Okay, okay. And I'll request all of you, please do not step out of your home. Okay, try to remain inside, right?
Yes, sir.
And make use of the most of the time that you're getting. Study well, prepare for your exams. Okay, in case you have any kind of doubt, you can contact us through WhatsApp, or you can create a Zoom meeting even in the evening. Okay, so we will be able to help you out, right? However, I'll request you, don't even if you're staying near the college, please don't go to the college right now. Okay, right? So the meeting will end soon, and I'll what I'll do is I'll end the meeting here, right? And soon after, at around maybe 2:40, you can, I'll again click on that link. I am available at 2:40. You just click on that link and we'll come back to this meeting once again. Okay. And I'll start with the resistance welding process, right? Okay. So I'm ending the meeting here. Okay.